Good afternoon. My name is George Bai. I'm the president and CEO, and actually the founder of Bai Aerospace. Years ago, I founded Bai Aerospace and our focus on electric aviation to bring about change, to bring about hope, to look at the future, and particularly to think about technology trends along with the economic trends, kind of the challenges that we face as pilots. And of course, 5, 10 years ago, we had a whole different set of economics, politics, the background here in the US as compared to the rest of the world, and the macroeconomic trends were all changing. And of course, last year, we had the pandemic, and that disrupted everything. We thought there for a while, with the pandemic in particular, that general aviation was going to be just crushed. Civil, business, commercial aviation did not look good. And yet here we are a year later, and Oshkosh is greater and better than ever before. That's really cool. I'm very excited about that. That also, however, introduces or reintroduces some of the challenges that we have that we were looking back 5 or 10 years ago around pilot training. When I was 8 years old, my mother introduced me to flying. My dad as well a little bit later, but it's actually my mother, Marilyn, and a little Piper Cherokee 140. Oh my gosh, the love of aviation became a part of my DNA. That same Piper Cherokee 140 is flying today. That could be a challenge. It's also kind of cool, but it might be a challenge. The economics of learning to fly when I was a youngster. Oh my gosh, the cost of fuel was almost nothing. And of course, in the late 1970s and early 1980s, the Arab oil embargo and the fuel costs forever changed. In the late 1980s, the resurgent, incredible industry that we know today as general aviation came to a halt because the economics of flying changed. The cost of fuel impacted all of us wanting to enjoy aviation either as recreation or as business or in the commercial realm. Not too many years later, a tremendous insurance issue came about, and as you may remember, some of you, in the late 1980s, early 1990s, general aviation not just ground down, but ground to a halt. Technology perhaps played a role. Certainly energy costs played a role. Regulatory issues, insurance issues all played a role. But today the fleet that is flying averages 50 years old. The age of pilots today is not a lot different than the age of the fleet, and I am one. I'm proud of it, and I know you all are too. But to inspire the next generation, like my mother did when I was a youth, to invite young people to fly, and again, I thank Jack Pelton. I believe he took ticket prices for 18 and under and just eliminated them to try to invite young people to come enjoy EAA. How cool. How awesome. Taking away the ticket price is not going to take you through pilot training, though. Some years ago, I was invited and very fortunate to have a tour through the very brand new technology roadster development for Tesla. I got a red carpet tour. I got to go through and see what the future of automobiles might look like. Now, I'm an engineer. I'm an Air Force pilot. Some of you know I flew T-38s. In fact, I'll tell you a story in a little bit about that. Trained fighter pilots, went to Desert Storm. I'm so fortunate to have a career in aviation. But I was fortunate enough in my kind of role emerging as focusing on new development, new technology, to have a tour at the Tesla developmental facility when they were just doing the brand new Roadster. And I might add, not very well. They were just figuring it out. The motor was big, the batteries were small, there was no range. Sounds familiar? Maybe to some. No range, small batteries, big motor, not very efficient, workmanship wasn't there yet, but they were crafting the future. Oh my gosh, did they have skeptics? They had skeptics all over everywhere. Nobody believed an electric car would ever emerge as a part of the industry that we all see today. But I saw something, and maybe some of you do too. There's just as much potential in electric aviation as there is in electric cars. If you can have a 3-hour driving time in a car, I can have a 3-hour flying time in an airplane. But it's more important to me because the cost of energy is so much more important. Avgas is about $5 a gallon, give or take, depending on where you live. That's the single largest objection to new pilots becoming pilots is the cost of training. The largest piece of that is the cost of energy, the cost of fuel. Tesla was a pioneer. Tesla fought the trends, recognized technology and the emergent capability of electric propulsion, what it might mean to electric cars and the future of that particular market. We saw the potential not just for an airplane as a novelty that might fly electric, but as a problem solver. The cost of electricity per flight hour is 1/10 the cost of the equivalent amount of avgas for that same flight hour. 1/10. Not a misquote, 1/10. Right in front of you, you see the eFlyer 4. We have the eFlyer 2 for pilot training, the eFlyer 4 for utility, air taxi, advanced training. That eFlyer 4 operating cost in total, with energy, with battery replacement reserves, with maintenance, is $30 per flight hour. $30. How much is a Cessna 182? And I love Cessnas, not picking on Cessna, but what's a Cessna 182 per flight hour? 160, 150, 180, depending on the part of the country you live in. If you're overseas, even more per flight hour. Imagine the paradigm change for primary training and for advanced training when you can solve the cost of energy and bring it down from aviation fuel costs to electric costs. It disrupts the industry. It changes the whole game. Now, right in front of you, one of the announcements we have here at Oshkosh is the further engineering and performance development of the eFlyer 4. That's the 4-seater that you see on the TV screens. If you look up in the front of the airplane, you'll notice one of the fundamental changes from legacy conventional aircraft to electric aircraft. Look at the nose of the plane. You notice how sleek that is, how streamlined the nose is? That's because in the front of the airplane is an electric motor, about 96% efficient, 50 to 80 pounds. eFlyer 2 is about 55 pounds. eFlyer 4 is a little bit more than that. So a Lycoming or Continental, 220, 240, 260 horsepower, at least a 350-pound engine that combusts fuel with air. Cooling drag on a conventional engine is tremendous, at least 14%, 15%, sometimes as much as 20% of the parasite drag of an airplane today is the cooling air needed to go across the cylinders to keep the engine functioning. On the eFlyer 4, that electric motor is 96% efficient. It does not combust with air. It's just electrons creating torque, creating thrust, and flying away. That reduced parasite drag is a big deal. Our lift to drag ratio on the airplane is about 20, compared to a Cessna, which is 9.6. So I have twice the aero efficiency, a much higher and more efficient electric motor, much lighter, and that gives me room for that 3-hour battery pack. A lot of people think I'm just trading avgas for electrons, avgas for batteries. That's not really completely true. I'm also trading it for greater aero efficiency, greater lift efficiency. Those airfoils are just designed to be ideal for aerodynamics. I don't carry fuel on the wings. I don't change my weight and balance. I take off with the same weight as I land. So I have a parasite drag reduction, an overall aero efficiency improvement, and that electric motor in exchange for the conventional engine and fuel is how the eFlyer 4 is created. And our announcement today at Oshkosh is about the eFlyer 4 evolving from the 200 knots at 200 kilowatts. So 268 horsepower, 200 kilowatts, at a 75% power setting, 200 knots. That's cool. That's really cool. Cirrus, about the same cabin width, 48, 49 inches. 200 knots of speed, efficiency, and 1/5 the operating cost. That's an amazing airplane. And when you can change the operating cost like that, keep the overall purchase price about the same, the eFlyer 4, just like its younger sibling, the eFlyer 2, will be just as disruptive in general aviation as the 2 is for primary training. So eFlyer 2, 2-seat primary training, eFlyer 4, 4-seat advanced training, as well as the utility for air taxi, air charter, a great advanced trainer, something we all here as fellow pilots would enjoy flying. And with a 330 nautical mile range and a 3-hour flight time, the utility to really go where you'd like to go, when you'd like to go. And of course, the cost of recharging, the cost of maintaining that airplane, such an improvement over the legacy aircraft that we'll be changing out of. So eFlyer 4 is one announcement. We'd like to go and also talk a little bit about the eFlyer 2. The program for the eFlyer 2 has continued to evolve. We're actually beginning to build serial number 1, production number 1 is in assembly today. You can see the developmental prototype here that's been flying for about 4 years. It's had several different configurations, 2 different motors, several different battery packs. And the bottom line for by Aerospace and for the eFlyer family of aircraft is that it's not merely a concept and a great design with great partners, but it's demonstrated flying for years. When I point out the cost of electricity is 1/10 that of a conventional aircraft, it's because we've been charging and recharging and flying this airplane for the last 4 years. That's real data. We talk about the cost of maintenance. It's real data with the airplane flying today. When we look at the design and development of the electric motor, the software in the motor controller inverter, the software in the battery management system and the battery packs and cooling and maintaining batteries, it's because the team has been doing that for 4 years' time. And as we go back and now look forward with the FAA, we had the administrator, Steve Dixon, and his leadership team come by just a couple of days ago. The FAA is very interested in helping make sure the next generation of airplanes like the eFlyer 2 and 4 come to market. And as a normal category airplane with the full utility of a Part 23 certification, the broadest possible applications can be brought to bear. eFlyer 2 in primary training, eFlyer 4 in advanced training. And the FAA recognizes, like all of us, the pandemic is now, well, hopefully mostly behind us, that we see Southwest hiring pilots, we see United hiring pilots. Meanwhile, the pilot demographic has continued to age. So back to my story about being 8 years old and my mom inspiring me to fly, we need to get these young people into flying. And the FAA recognizes their role in working together with a pioneer like Aerospace and setting the regulations, writing the regulations, and bringing to market through the type certificate process, and then to follow the production certificate process so that we can deliver airplanes to our customers here in the United States and, of course, around the world. So the eFlyer 2, two-seat primary trainer, 3 hours of flying time, 138 knots. Of course, the average sortie length as a trainer is about an hour, 1.2, 1.3 hours. Recharging the eFlyer 2 takes about 20 minutes. It turns out it's about as fast and maybe even faster than refueling with avgas. eFlyer 2 is about a $500,000 airplane, depending on options. Of course, some want more advanced radios or dual radio sets. Some are more primary configurations. Some people will like a nicer paint or interior. All of that's standard for any aircraft, no different for the eFlyer 2. A $5,000 deposit is required to hold a production position for the eFlyer 2. The eFlyer 4, right next to its younger sibling, 4-seat airplane, 200 knots, 3 hours of flying time, 330 nautical miles, and we go from a 46-inch wide cabin to a 48-inch wide cabin. Again, very, very similar in configuration to a Cirrus or that capability of aircraft. The eFlyer 4 is in the mid-600s, maybe 700,000, again, depending on the options. If it's a Part 91, Part 135, if it's a primary owner-owned airplane, or if it's more of a fleet-type aircraft. Interestingly, thus far, our market's been more on the fleet side, as you might imagine, for the eFlyer 2, more on the fleet side for the eFlyer 4. Again, the operating economics are powerful when it comes to a fleet operator looking for air taxi or air charter. Even small cargo, as you might imagine. No noise, no CO2, disruptive benefit in terms of economics. And then next to the 4, some of you have seen that about 2 months ago, we announced the eFlyer 800. So we go from 2-seater to 4-seater to 8-seater. Same systems, same technology, just an iteration from a 1-motor to a 2-motor configuration. Same battery pack technology, same Safran motor. Now, not identical, but same industry partner, of course. It's a 500 kilowatt dual wound motor on each of those pods. Safran joined us in announcing the eFlyer 800. L3 Harris is working with us on defense applications. Our great friends at Jet and Jet Club, we announced just a couple of weeks ago, their fleet order is our launch customer for the eFlyer 800. And of course, Glenn Gonzalez and his team at Jet and Jet Club in the US and across in Europe, we're just delighted to work with them as they bring electric turboprop category performance to the market for business, for air charter, for on-demand air taxi. This eFlyer 800 is a game changer. It doesn't consume oxygen, as I mentioned before. So we're altitude agnostic, meaning I don't diminish in torque and horsepower, if you will, as I climb. So the eFlyer 800 is a 35,000-foot ceiling, pressurized. High-speed cruise is 320 knots with a 1,540-pound payload, 8 seats. A true 8-seat aircraft. There's no fuel payload exchange with electric. So a 500 nautical mile range for Glenn with a 45-minute IFR reserve absolutely changes the benefit to him and his customer with this transformative airplane. Last week we announced our first European customer with Rhineland Air Service. They took some eFlyer 800s. And then here earlier this week, we announced another customer, Sky Aviation, that's going to lease eFlyer 800s to their customers. Here at this show, another customer came to us and asked us for another 20 aircraft, a total of 40 eFlyer 800s. So even in just the last few weeks, 2 months of time or so, the eFlyer 800 has begun to put down roots as we look to the future of general aviation and business aviation with the benefits, the disruptive benefits of electric propulsion. One of the things that's changed since we began the company has not just been motors and batteries. It's been the sensitivity to the environment. And whether it's our friends in Europe or here in the US, there's a greater sensitivity to the amount of CO2 we put in the atmosphere. Sustainable fuels, sustainable aviation has been something that's been brought up across all politics, across all the industries impacted by aviation. Our role at Aerospace, of course, is the electric propulsion system with our new eFlyer aircraft. AOPA, Gamma, all of the leaders here at the EAA, all of our friends here in the industry, NBAA, are all concerned about and paying attention to sustainable aviation. Electric aviation is the tip of the spear. Of course, there's much, much more to it. We understand that. How is the grid powered? I understand that. That's not what we do. We do the electric aviation part. But of course, there's more to that broader, larger question. But OSM Aviation in Norway has 60 eFlyer 2s on order. Scandinavia is really interested in all things electric. There are going to be parts of the United States that lead, other parts of the United States that follow. Friends in Europe and Asia and around the world, some have greater concern about electric and CO2 than others. But the bottom line is, we have now translated with the technology where there's very little compromise when you buy an electric vehicle. There's very little compromise when you buy an electric airplane. One critique I will embrace is that we're a little bit shorter on endurance, but not much. This eFlyer 4 with a 200 nautical mile, or 200, knot speed and 330 nautical mile range, that is a real sweet spot in terms of being able to do the business of aviation. Certainly advanced training, air taxi, along with primary training in the eFlyer 2. 500 nautical miles with the eFlyer 800 is a game changer. And the majority of the work that we do is 440 nautical miles or less. In fact, 95% of business charter operations are 440 nautical miles or less. I can't do all the missions, but I can do a lot of them. And I can help our friends in business aviation with their mission with this airplane. About half of our airports are based in urban environments, in cities. And the people who want to train, of course, and become the future pilots live in those communities. Airport noise is important to all of us. And electric aviation, along with eliminating CO2, also eliminates noise. And that's pretty cool. Our friends at Centennial Airport and the aviation partners we have there, of course, flying every day in the training mission and the business mission, noise matters to them. And I'm very proud. The amount of noise from an electric aircraft is about 30 decibels less than a conventional aircraft. In other words, 1,000-fold quieter. Again, for some communities, that's a really big deal. We come full circle back to my mother. We come full circle back to the youngsters today wanting to learn to fly. And the operating cost per flight hour is the key disruptor, whether it's the eFlyer 2, the eFlyer 4, or the eFlyer 800. When you sum up in detail, you can see the eFlyer 2 is about $24 per flight hour. And that's taking into account battery reserves. We're setting aside capital in the operating costs to replace those batteries on a regular basis. So I'll finish with a war story. Again, I mentioned I'm an engineer, Air Force pilot, and no offense to Navy pilots out there, or Marine Corps, great Army, no offense. Air Force pilot. I flew T-38s out of Shepherd Air Force Base, the Euro-NATO Joint Jet Pilot Training Program, NJEPT. And I had what's called an instrument out and back. An instrument out and back training mission with fellow pilot, a student pilot. Of course, NJEPT's focused on being fighter pilots. The only way you graduate out of NJEPT is if you qualify to be a fighter pilot. If you don't, you don't graduate. So it's kind of a higher stress situation. We have additional check rides. We have additional focus. There's additional intensity and stress. So we took off for this instrument out and back training mission. I took off, and as I was flying, the student's in the front seat, I'm in the back seat. Oh, pardon me, it's the other way around. It's instrument training. I was in the front seat, he was in the back seat. And, of course, just religiously flying his procedure as we head out down to Amarillo, I get a call from the supervisor of flying. My boss says, "Captain Bai, return to base." We have weather coming in. Thunderstorms are building. You need to cut your training mission short, return to base. We have a situation. Warbird noise is so cool, but electric doesn't make noise. Anyway, so there's trouble brewing. There's clouds growing. Thunderstorms are coming. George, you need to change course. You need to change course. You need to do something different because trouble is coming. So I turned the airplane around, called Fort Worth Center, said emergency, return to base, weather, etc. They gave me a new clearance. Started back. The students kind of going, oh, I don't know, what's going on? Of course, that's what students do, right? That's okay. So I gave him the control of the airplane back again. He's trying to follow radar vectors back to Shepherd Air Force Base. As we get closer, I'm looking out on the horizon, and there's this thunder boomer's just going up as far as the eye can see. Of course, the student's sitting there up, just kind of trying to fly. Who's looking out to see if there's trouble coming? Who's paying attention to what's on the horizon? Well, the instructor was, that's right. I knew my life was on the line, but he was sitting in there just focused on just trying to fly the airplane. We got closer to the base. This monster thunderstorm was just right in front of us. Students focused like this, and I'm going, expletive, expletive. Now, what's interesting is the regulators of flying, air traffic control, can't see the weather either. They're saying, hey, turn right 270, descend and maintain 4,000, expect further clearance, blah, blah, blah. And I'm going, is anybody paying attention to the weather? They can't see. My student's just trying to dutifully fly the course. This monster is in front of me. Into the thunderstorm we go. I'm on downwind. Descend to 3,000 feet. Perform landing checks. We've all heard that, right? The monster is getting darker. Rain starts to pound the front of that T-38. And of course, T-38s fly at 300 knots. That's your normal pattern speed, 300 knots. Just rain pounds on the front of that canopy. Is anybody paying attention to this crisis growing in my airplane? My commander comes on, Captain Bai, you're the last airplane, see if you can get it on the ground. And I'm going, you know what? I can't even punch out of my jet anymore. I'm committed. My life is on the line right now. What comes after heavy rain and a thunderstorm? Hail. Oh, hail, yes. Here it comes. Boom, 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 boom. Canopy's just getting beat like crazy from the hail. My students up there going like this. Air traffic controllers, maintain heading. I'll call your base. And I'm going, hail no. Turn the airplane hard to base. Declare an emergency and say, something has to change right now or we're going to die. Now, some of us have a fair amount of flying time. Some of us know you can intercept an ILS, not at the final approach fix, but you know that localizer is going to be there. You know the glide slope is going to be there. Sometimes in an emergency, you have to trust your airmanship. Sometimes in life, you have to trust your judgment. Sometimes you need to see the storm that's brewing in front of us. I made that turn. I declared an emergency, and I said, we're going to trust in good faith that that instrument approach is where it's always been. I can trust that it will be there for me. And I found that localizer. I hit that glide slope, and I landed that jet safely that day. Students going, what the heck just happened? And I'm going, somebody's prayers were answered today because we're alive. And as I landed, the gust front from that thunderstorm came right behind me. Driving rain, dust, roll cloud right behind me. Thank God for angels on my wings. But as well, I think we have to recognize in our industry, we're facing a crisis of pilot training. We're facing a crisis of an aged fleet. We need the next generation of pilots. We need the next generation of technology to take us to the future. That's what I'm committed to at Aerospace, and I'm committed with my team and our great friends in our supply chain, our great friends in our market, to bring us together to a safe landing. Thank you.